Hello, I'm Joe Burke, a principal member of the EAGOGICS Engineering faculty and author of Unleashing Engineering Creativity, our latest book. Unleashing Engineering Creativity is also the name of our workshop on this topic, available for customized presentation worldwide. We at EAGOGICS are passionate about creativity. We've dedicated a special page of the EAGOGICS website to our Creativity Resource Center, featuring several free resources including articles, podcasts, videos, and more. I encourage you to share this page with your coworkers, bosses, subordinates, and others. The URL of this page appears at the top of each slide of the presentation following this brief introduction. The focus today is on TRIZ, the theory of inventive problem solving. TRIZ is an elegant technique that allows us to use existing concepts to solve complex creativity challenges. It is a powerful and effective design tool. I'd like you to consider your company's products. Are these always completely new products, or are they adaptations and improvements to existing products? In most cases, I think you'll agree, our products tend to be improvements of earlier products. What Altshuler found in developing the TRIZ concept is we don't have to limit our search for creative solutions to our own product lines or even our own industries or technologies. If we look beyond our technologies to see how others have solved problems, we frequently find applicable, innovative ideas. Consider, for example, the bolt-action rifle. Let's take a look at this elegant old Mauser bolt-action rifle. The way the bolt operates: to open, you twist it, pull back, to close, you push it forward, and then rotate it to lock it again. Very, very beautiful rifle. Paul Mauser's inspiration for the perfection of the bolt-action rifle came from a simple gate lock. Take a look at this latch. We rotate it, we move it back to open it, we push it forward to close it, we rotate it down to close it. It's that kind of similarity that TRIZ alerts us to. With this as a brief introduction, let's move into a more detailed TRIZ discussion. Let's now turn to the PowerPoint portion of our presentation on Unleashing Engineering Creativity. As you know, and as I mentioned a second ago, our workshop covers approximately 20 different engineering creativity techniques. They're outlined in our book, Unleashing Engineering Creativity. Everyone who takes the Unleashing Engineering Creativity workshop is provided with a copy of this new reference. It was just published this year. You can also purchase it separately by going to our EAGOGICS Creativity Education Center at www.eagogics.com/creativity. I'd invite you to take a look at the book. I think it's an excellent reference. Our focus today is on but one of the 20 engineering creativity techniques. Our focus today is on the theory of inventive problem solving, or as it's abbreviated, TRIZ. We'll see how we got that acronym in just a few moments. One of the things I would invite you to do is to take a quick test. And I'd invite you to do that while you're listening to this presentation. So while I'm chatting, get a piece of paper or your computer or your cell phone or whatever is convenient, and I'm going to ask you in 1 minute to think of as many possible uses as you possibly can for an empty tin can. Just let your mind go wild and come up with as many ideas as you can, and let's start that right now. Take 1 minute. Okay, we've got about 45 seconds left. Got about 30 seconds left. "15 seconds left. Think of as many ideas as you can. Write them on a piece of paper. Do your best.
And stop. Now, before we go on to the next slide, I'm going to challenge you and I'm going to ask you a question. Most of you are engineers if you're listening to this presentation. This workshop is focused on engineers. And I'm going to guess that, like me, I'm an engineer too, you probably think you're a pretty creative person. Consider this. Were you more creative as a kid or are you more creative now? Did you become more creative as a result of your engineering education? Think about those answers. They may surprise you when you compare them to this next slide. What you just took was the Torrance test of creative thinking, in which you're asked to identify as many possible uses as you can think of for an empty tin can. And what I'd like you to do now is evaluate them from 4 perspectives: fluency, flexibility, originality, and elaboration. Fluency is simply how many total ideas you came up with. What's the quantity? Flexibility describes ideas in different categories. Originality, and that's the one we're most interested in, originality involves using the tin can for something other than its original intended purpose, which was to hold things. So I want you to consider your total list of ideas, and then within that total list of ideas, identify how many ideas don't involve the tin can being used as a holder for something. That's your originality score. And elaboration is how much detail you go into on each of your ideas. But that one that we're most interested in is originality. And you know what we find is kids who are 5 years old, folks in kindergarten, have the highest score in that area. And what we find is our ability to come up with completely original ideas, completely original uses for an empty tin can falls precipitously after kindergarten. Until when we finish high school, it's only about 2% of what it was. You might ask yourself, why is that? What happens to cause our creativity to deteriorate so significantly? Well, think about it. In kindergarten, we get construction paper, a multicolored box of crayons, and we're just told, go draw things, and it was great. We could draw whatever we wanted to. Then came first grade, we had to learn to draw between the lines. We had to learn how to write letters. Then we had to learn how to write letters between lines. Then we had to learn uppercase and lowercase letters. Then we had to learn cursive writing. Then we had to learn spelling, punctuation, grammar, paragraph construction. We had to learn mathematics, physics, chemistry, etc., etc., etc. And then for us folks who went to engineering school, we learned all the physical laws, F equals ma, physics, more chemistry, statics, dynamics, electronics, circuit design, etc. And you know what happens? By the time we finish our engineering educations, we're even less creative than we were when we finished high school. And the reason for that is our creativity is stifled. We don't take courses in how to be creative. We take courses in how to obey the rules, how to use the physical principles, how to solve problems using approaches prescribed by others. The emphasis on creativity is very, very low. That's the bad news. The good news is there are a lot of things we can do as engineers to get this back. I guess I'd add one more note on this chart. You know, it's even worse once we start working as engineers, because then most of our creativity is focused on satisfying someone else's specification at the lowest possible cost. That's usually how we get work. So let's consider this, and let's move on into some new areas associated with TRIZ. TRIZ is an acronym that comes from the Russian words for the theory of inventive problem solving. It was created in the former Soviet Union by a fellow called Genrikh Altshuler, who was a Russian Navy patent officer. Altshuler observed that most of the patent applications he reviewed really weren't anything new. His idea was that most patents involved applications of existing principles or earlier ideas that had been adopted to solve new problems. Well, you might imagine this didn't go over very well in the former Soviet Union, particularly under Stalin.